Hello, everyone. I hope I have not stopped the questions in between, but I think we covered a lot of questions. So now let's start on what is a countdown latch in Java. It's a part of Java itself. So if you can see by here, we are seeing that countdown latch is the class which actually helps in implementing the synchronization in Java. Okay, there are many methods which actually do that. But what is the benefit of countdown latch or how it works is basically what are the scenarios it is actually used. So if you can see, it is used right now into a scenario where there are one or more threads which have to wait until other threads have reached the same state, such that all threads can start, right? Basically, if one or two threads are waiting for another two threads to complete so that all of them can start. So that's where countdown latch works. So there is actually a synchronized counter which decrement until its value reaches to zero. Once it reaches to zero, right, it means that all the waiting threads can proceed now. So it is a versatile tool that can be used for synchronization scenarios. It's also work as a on-off latch or gate. All the threads invoking a wait method wait at the gate basically until the gate is open for all. So you can't just go one by one. Then what is the difference between a countdown latch and a cyclic barrier? So see, you can see a countdown latch and a cyclic barrier, right? Cyclic means it's all goes into a circle. Just very lame explanation, but I'll tell you what it is. Cyclic barrier basically it takes an optional runnable task that is run once the common barrier condition is achieved. Okay, so understand this point. Cyclic barrier, right? It takes an optional runnable task, and that task will run once the common barrier condition is reached for everyone. But in countdown latch, it's simply a use case where a simple whenever you want a simple start and stop. So cyclic barrier is useful for a complex scenarios where there is more coordination that needs to be required, like map reduce algorithm implementation and all. And cyclic barrier actually resets the internal value to the initial value once the value reaches to zero, and it can be used to implement multiple scenarios, like where thread has to wait for each other multiple times. Here, that for countdown, it's basically you have to wait till the time your all the threads have to come into a zero position. Cyclic barrier goes into much more different combinations, and that's where it is used. Okay, so what are the scenarios suitable for fork or join framework? So fork join pool is a class which is in the center of the fork or join framework. So it is a thread pool that can execute instances of fork join task. Okay, now what does a fork join task is? It provides two methods, fork and join. The fork method start the asynchronous execution. Join methods actually wait till the computation is completed. Therefore, all the divide and conquer algorithms can be easily implemented with this, right? Now, what is the difference between a recursive task and a recursive action? So recursive action actually has a class that class has a compute method that will not return a value. So it can use to directly operate on a data structure so that because it does not need to return any computed value. However, the recursive task class, the compute method is there, which will return a value. So that is what the difference between both of them. So in Java, we can process stream operation in a thread pool. Actually, yes, stream operations can be processed with the help of parallel stream, and we can also call the immediate method parallel on a given stream to convert it into a sequential stream of parallel tasks. So sometimes people ask the difference between stream and parallel stream that can be useful for you. So now the second useful scenario is what are the scenarios to use where we can use the parallel stream. Okay, so parallel stream in Java 8 has a much overhead compared to a sequential one. So basically, it takes a different amount of time, significant amount of time to coordinate between the threads. So what happens? So we can use the parallel stream, but under these scenarios, like when there is a large number of items to process, and the processing time of each of the items is means different. Okay, and can be the items can be the processing time can be parallelizable. Second thing, when there is a performance problem in the sequential processing. Third thing is when current implementation is not already running in a multi-threaded environment. If there is already a multi-threaded environment, adding parallel stream will actually degrade the performance. Okay. Now, how stack and heap work in a multi-threaded environment? So basically, stack and heap are memory available to an application. Every thread has its own stack, and where it stores the local variables of the thread, like parameters and other call stack. Now, local variable stored in the thread or stack of one thread is not visible to another thread, right? Whereas in heap is a common memory in JVM. So heap is shared actually by all the threads. So to summarize, a stack is for each thread, right? But heap is like shared memory. So all objects are created inside the heap. So basically, to improve performance of this thread uh, the thread can cache the values from heap into their stack. But what will happen? This can create problem, right? If the same variable is modified by more than one thread. So in such scenario, we will use the volatile keyword to mark variable volatile. For volatile variable, the thread will always read the value from the memory, not from anything else. Okay. And how can we take thread dump in Java? So the steps to take thread dump of Java process depends on operating system. So on taking the thread dump, Java writes the state of all threads into a log file or a standard error console. And we can press the control break key together to make the thread dump. Or we can execute the kill -3 command. This is very into it's most into the backend processing, like system administrator. So I'll not move much deep into it. Now, which parameter can be used to control the stack size of a thread? We can use the -x small s parameter, and if we set it to 1 MB, then every thread will get a 1 MB of stack size. Now there are two threads, suppose T1 and T2. How will you ensure that these threads run in a sequence? So basically, we'll have a join method. We'll first run T1, and then we'll say T1.join, and then we can call the T2, right? So yeah. So now it stops here. The threads stops here. There are multiple playlists on Java thing and all the threads, so you can use it there. Okay. So bye bye.